Okay, this is section 1.8. In this section, we're dealing with absolute value equations and absolute value inequalities. The goals of this section are to be able to solve absolute value equations, to be able to solve absolute value inequalities, and to be able to express distance and tolerance by using absolute value. So absolute value is a useful thing whenever you're trying to determine the distances. It comes in handy, or whenever you're trying to determine tolerance. So this is the first part of this section. This section has two parts. In this first part, we're going to be dealing with absolute value equations and using absolute value for expressing distance and tolerance. In the second part, we'll do absolute value inequalities. Okay, so let's get going. Some preliminaries for this. Well, understanding absolute value. The absolute value of A is just the distance from A to 0 on the number line. You can think about it as one-dimensional distance. It's distance in the number line. So yeah, the absolute value of A just means how far is A from 0 on the number line. What about this equation? The equation absolute value of x equals A. That equation can be solved by finding all of the numbers that are a distance A units from 0. So this equation, absolute value of x equals A, is satisfied by all of the numbers that are a distance A from 0. And well, the numbers that are a distance A from 0 happen to be, well, negative A over here and positive A. Yeah. So the solution set to this equation is the value negative A and A. Why? Because both of them are a distance A from 0. Okay. Now this inequality, absolute value of x is less than A, is satisfied by all of the numbers whose distance from 0 is less than A. So all of the values whose distance from 0 is less than A. So I think this picture here kind of shows what the solutions look like. It's everything that's less than A away from 0. So 0 is right here in the middle, and it's all the things that are less than A away. So things whose distance is less than A from 0. So it's everything from negative A to positive A. And right now, since I'm using this type of strict inequality, I'm going to be using parentheses. So the solution set to this inequality, absolute value of x is less than A, is parentheses negative A to A. Now this other inequality, the absolute value of x is bigger than A. That is satisfied by all the numbers whose distance from 0 is more than A. So this inequality right here is satisfied by all the numbers whose distance from 0 is more than A. So you have to be more than A away from 0. So this picture here kind of shows the solutions. Things that are a distance more than A. So if A is right here, are things that are further to the right or further to the left from negative A. So the solution set for this inequality, absolute value of x is bigger than A, is this union of intervals, negative infinity to negative A, union A to infinity. And to summarize these three things, I made this little table right here. I don't know if it helps. Well, it's going to be a good guideline in order to solve more complicated equations and inequalities. So if you have the absolute value of x equals A, in order to actually solve such an equation, what you can do is break it up into two equations. One which says x equals A or x equals negative A. So this is going to be useful for us whenever we're solving here in a second more complicated absolute value equations. Now, if you need to solve an absolute value inequality of the type absolute value of something is less than something, well, this is how you would want to work with it. You would want to break it up into this compound inequality. X is less than A and x is bigger than negative A. If you are dealing with the absolute value of x is bigger than something, than A in this case, well, then that splits up also into two inequalities. One of them is x is bigger than A, or x is less than negative a. Things that are a distance more, a distance more, how would you say it? More than a units away from 0. Okay, so keep this, so this is the absolute value equation. This is its equivalent form without absolute value. This is the absolute value inequality. This would be the equivalent non-absolute value inequalities. This is the absolute value other inequality, and this is its equivalent form over here. We're going to be using these equivalent forms to solve, so keep this in mind. Okay, let's get into some examples then. Let's solve some exercises here. The first thing we're going to do is solve some absolute value equations. So there are 3 absolute value equations to solve. Here's one of them, the absolute value of 9 minus 4x equals 7. Here's another one, the absolute value of 3x minus 2 equals 0. And here's a third one. There is a third one, believe me. It's just my computer is doing its usual freaking out. Sorry, give me 1 second while this thing loads back up. Come on. Sorry, technical difficulties. Okay, so we have some absolute value equations to solve. At this point, you should write them down and try to solve them on your own. So here's the first one, second one, and third one. And by the way, this is a negative 8 right here. This is supposed to be negative 8. So solve them. Pause the video, see if you can come up with solutions for them. And then let's just compare answers after you finish working on them. Okay, so let me get going with the solutions here. So if I have the absolute value of something equals 7. What I know I can do, according to my little guidelines up here, is I can break this up into two equations. One of them, so I have the absolute value of x equals something. It's going to be x equals the thing, or x equals negative whatever you have. So right now, this is going to split up into 2 little equations. One of them is going to go like this. 9 minus 4x is equal to 7. And the other one is going to go something like this. 9 minus 4x is equal to negative 7. And now I gotta solve both of them. But these aren't too bad to solve because these are just linear equations. So let me solve them. Let me subtract a 9. Okay, so that says negative 4x equals negative 2 over here. And over here I have negative 4x equals negative 7 minus 9. That's negative 16. Then I'm going to divide everything by negative 4. So if I divide negative 2 by negative 4, that's 1/2. And over here, if I divide everything by negative 4, I'm going to have x is equal to positive 4. And that's it. So my solution set is 1/2, 4. By the way, notice that I use these little curly brackets over here. This is a set. This is a set that contains only the elements 1/2 and 4. So don't think this is not an interval. This is just a set that contains 2 individual numbers. Okay, so that is my answer for the first absolute value equation that we have. Hopefully we agree. Let me move on to the next one. The absolute value of 3x minus 2 equals 0. Okay, well, we're supposed to split this equation up into two. One of them that says 3x minus 2 equals 0 and 3x minus 2 equals negative 0. But negative 0 makes no sense. So this is actually kind of a simple situation here. Whenever you have an absolute value equation and so you have something in absolute value equals 0, well, it's just equivalent to setting up the thing that is inside of the absolute value equal to 0. So this is equivalent to just saying 3x minus 2 equals 0, and that's it. And then solving this. So in this particular case, this would say 3x equals 2, because I added 2 to both sides, and then I will divide by 3. So x equals 2/3. And that is my answer. The solution set is 2/3. Another way to think about it, I mean, we could think about these things graphically as well. We could think about these things graphically. What's going on here is that you have, so let me actually sketch the little picture of what's going on. You can think on the left hand side right here, this is, think about the absolute value graph. It looks like a V. And some transformations have happened here. We've reflected on the y-axis, and then we have shifted this graph around a little bit. So there's some transformations of the absolute value function that have happened, and we want to know when it's equal to 7. And think about the graph of 7. 7 is just a horizontal line. So right now what you're asking yourself is, when does the graph of this V intercept the graph of this horizontal line? And well, it turns out that the intersection happens at 1/2 and at 4. Over here, what's going on, if you think about it graphically as well, is that you have the graph of, on the left hand side, the graph of this absolute value function. Again, it's some type of V that points upward. And right now what you're asking is, when does it hit the x-axis? When does it hit y equals 0? Well, it hits the x-axis only at the point 2/3, because that's where its cusp got moved. So you can also think about these things graphically if need be. Let's solve the last equation. Let's solve the last equation here if my computer wants to load it. Okay, so here's the last equation. I have this one's a little bit more complicated looking. Absolute value of 3x squared minus 14x minus 5 equals -8. Whenever you're dealing with absolute value equations and inequalities, you want to be careful. One thing to keep in mind is that the absolute value is always positive. Absolute anything. So here I have some x's. It doesn't matter what choice of x I make. It doesn't matter what choice of x I make. Once it goes inside the absolute value and it gets processed by the absolute value, the output will be positive, no matter what value of x I start with. So what I can say about this equation right here is that the left-hand side is always going to be something positive, because the absolute value always makes things positive. So the left-hand side of this equation is always positive. So can it ever be equal to -8? And the answer is no. The left-hand side can never be equal to -8. Graphically speaking here is you have the graph of, you have some graph that is always above the x-axis on the left-hand side. And on the right-hand side of this equation, you have a horizontal line that hits the y-axis at -8. Well, they're never going to intersect. So this equation, I would say that this guy is kind of tricky. This is sort of like a trick questions here. So what I can say here is that the absolute value is always positive. So we're going to say that there is no solution. No solution, or another way to express no solution would be to say it's the empty set. Yeah, it's the set that contains nothing. So be careful with this. This will also be the case whenever we're dealing with absolute value inequalities. Remember that the absolute value is always positive. So you always gotta kind of be careful here. If you ever have something absolute value, and then you might have an equal sign or an inequality, but then on the other side you have a negative, you should pause for a second and just kind of be careful. Think about what's going on. Okay, so let's move on then. Let's use absolute value to express distance and tolerance. So here's a couple of exercises. What you're supposed to do is you're supposed to write an equation or an inequality using absolute value, which represents the statement given to you. So here's the first statement. The distance between A and B is 2 units. And you want to use absolute value, an absolute value equation to express this statement. The distance between A and B is 2 units. There are 2 more statements here that I want you to try, but just give me a second here for my computer to work with me. Come on. This is silly. Okay. So these are the 3 statements. The distance between A and B is 2 units. M is no less than 5 units from 8. And T is within 0.02 units from 5. Yeah, this is supposed to be 5 here. Sorry, let me... So the last statement should just read, T is within 0.02 units from 5. I don't know how this 8 ended up there. Let me erase it. What happened now? There we go. There we go. Okay. So pause the video, take a couple of minutes and try to see if you can come up with the correct absolute value equations and inequalities for each one of these statements. All right, let's see. So let me begin with this question 4 here. So the distance between A and B is 2 units. So how do I find the distance between 2 points on the number line? The distance between A and the distance between B. Well, I hope that you agree that it's just the difference between them, yeah? The difference between them, and remember, a distance is always positive. So I'm going to say this. I do not know if which one is to the right of which one. Which one is B to the right of A, or is A to the right of B? I have no idea. I don't know which one's bigger. And it doesn't really matter. What I'm going to say here is the distance between A and B is just the absolute value of the difference. A minus B. You could also say B minus A. It doesn't matter. Both of them is the same thing. So for instance, you could say absolute value of 7 minus 2, that would be 5. Or the absolute value of 2 minus 7, that would still be 5. So you could say, I don't know, let me use the top one. So I'm going to say the absolute value of A minus B is supposed to be 2 units. So the distance between them is 2 units. So I think that is the equation that I want right there. Now you could also have written it as the absolute value of B minus A equals 2. That would have also been correct. Okay, next little problem. M is no less than 5 units from 8. What does no less mean? I said no less means that it has to be bigger than or equal. Now if you had a statement that said no more, something is no more than something else. That means that it's less than or equal. Yeah. So right now I'm dealing with an inequality. So let's see. M is no less than 5 units from 8. So that means that this is saying that the distance between M and 8 is less than or equal to 5. And if you think about it like that, so that's what this statement is saying. M is no less than 5 units from 8. So the distance between M and 8 is less than or equal to 5. Those things are equivalent. So as an absolute value inequality, then this goes like this. The distance between M and 8 is less than or equal to, bigger than or equal to. Sorry, let me erase that. Bigger than or equal to 5. You could also use absolute value 8 minus M. That would also be correct. Because that's the distance between M and 8. And that's my answer. This is my answer right here. This is my answer up here. Okay, the last one. T is within 0.02 units from 5. So let's think about the distance, like a distance statement first. What this is saying here is that the distance between T and 5 is 0.02, if you think about it. So right now what I'm saying is that the distance between T and 5 is less than 0.02. That's what this statement is saying. Okay, well, distance between T and 5, that just means absolute value of T minus 5 or 5 minus T, whatever you like. And this is supposed to be less than right now, 0.02. That's what this statement is saying. So T is within this much units from 5. So the distance between T and 5 is less than 0.02. This is talking about a tolerance. The tolerance, yeah, some little error, some little margin. Okay, so absolute value is definitely useful for expressing distances between points. So anytime that you see an absolute value, you should just think to yourself, oh, that's just referring to the distance between two things, because that is kind of what's going on. Okay, so in the second part of this video, we will be solving absolute value inequalities. So I'll see you in that video, and thank you.